Hello everyone. Um, Hello, welcome to my YouTube channel. So my already subscribers, thank you so much. I love you this much. Thank you so much. If you're new here, welcome to my YouTube channel. Make sure you like, you comment, you subscribe, and share to those that might need this video. So on the last video, we already started calculus, specifically differentiation, and we started off with power rule, product rule. Now today we are looking at quotient rule. And what does quotient rule of this derivative state? It states that derivative of u over v with respect to x is simply v du dx minus u dv dx, all divided by v squared. When you hear something like dv dx, means that derivative of v with respect to x. When you hear something like du dx, means derivative of u with respect to x. Now, and the way quotient rule works for an entity that division is the sign between them. That is two different, an expression. It could be a trigonometric expression or a trig function or something like that. And but the sign between them is division. That's where quotient rule comes in. We did product rule last class, and you could see that product rule actually works when you have multiplication between two entities or two expressions or two entities or whatever you can think of. But products, that is multiplication, is what is between them. But in this case, for quotient rule, division is the sign between these two entities. Now, we have an example here that will drive home the point much more. We have an example here that reads, if y is equal to x squared plus 6, all divided by 2x minus 7, we are asked to find dy dx. So we are using quotient rule. Another thing you need to know is that you should be able to know what rule you are going to use whenever you see a question. You should be able to know. We'll look at that on the next video. So let's quickly do this now. We're asked to find dy dx, given that y is equal to x squared plus 6 over 2x plus v minus 7 rather. So let's x squared plus 6 be equal to our u, then our 2x minus 7, let it be equal to our v, and let's see what we can do with that. So let u be equal to x squared plus 6, and let v be equal to 2x minus 7. Now, as I said in the last video, that whatever parameters you need, you would know them by the formula you are supposed to use. So if you look at this now, we could see that we need du dx, so we need to differentiate u with respect to x. So if we do that, du dx becomes what? 2x. Remember that I said you don't differentiate constant. Derivative of constant is 0. Also, dv dx is simply what? Just 2. We can't differentiate 7. It's 0. So let's quickly put this into our formula and then see what we're going to have. So dy dx now. Dy dx is simply, what is my v? V is 2x minus 7. Remember, multiplied by, that is dot. What is du dx? Du dx is 2x. Now, minus, what is my u? My u is x squared plus 6. Now, all multiplied by dot. What is dv dx? dv dx is 2. Now, remember that the whole of this is being divided by v squared. Is the square of v. What is v? V is 2x minus 7, then the square. So now let's simplify this for this to look much more beautiful, or beautiful to behold. Let's call it that. So if I do this now, 2x by 2x is simply what? 2x by 2x is what? That's 4x squared. This by this, that's negative 14x. Then 2 by x squared, and negative becomes negative 2x squared. Then 2 by 6, and negative becomes what? Negative 12. Then remember, the whole of this is divided by divided by v squared, which is what? 2x minus 7 all squared. You need to know that it's not all the time that you need to actually expand your v square. Sometimes that you don't need to. In this case now, we really do not need to, because if I simplify this, there won't be any form to simplify it, like the top and the bottom. So it's just best to leave your v square the way it is. So let's look at this now. So if I simplify this now, if you see, if I to factorize, what's common here? 2 is common. On the numerator part, 2 is common. So if I bring 2 out here, what will I be left with? I'll be left with 2x squared minus 7x, then minus x squared, then minus 6, minus 6. I use my brackets. So the whole of this is being divided by 2x minus 7 all squared. But if you look at this, there's x squared here. I can bring this together. 2x squared minus x squared is simply x squared. So my final answer here should simply be 2. Then I have my x squared, then minus 7x, then minus 6, all divided by 2x minus 7 all squared, and that's it. Now let's take one more example just to drive home our point. So if I have another example here, let's call this example 2. Example 2. So if we have that y is equal to 2x plus 1 over 3x minus 4. Then we're asked to find dy dx. So you know already, this is my u, this is my v. So if this is my u and this is my v, so I know that my u is equal to what? 2x plus 1. My v is simply what? 3x minus 4. What's the derivative of u? You know I need my du dx. My du dx is simply what? Just 2. And my dv dx is simply what? Just 3. So if I slot in my parameters here into the formula, my dy dx will simply be what? Dy dx will simply be, what is my v? My v is 3x minus 4 dot, what is my du dx? Du dx is 2. Then minus, what is my u? My u is 2x minus 1. So that's 2x plus 1 rather. Then dot, what is my dv dx? dv dx is 3. Remember that the whole of this is being divided by, what's my v? V is 3x minus 4. So I have 3x minus 4 all squared. So let's quickly tidy up numerator and let's see what it's going to look like. So this will look like what? Let's quickly write this here. If I'm to tidy up the numerator, this becomes 6x minus 8, then minus 6x, right? Then minus 3, yeah, all divided by 3x minus 4 all squared. So if you look at this, 6x and 6x goes out. So it becomes what? Minus 11. My answer is simply minus 11 over what? 3x minus 4 all squared. As you can see that you really did not need to simplify the v here, that is the v squared. So that's basically all we have here. So bye, thank you, see you in my next video. Make sure to like, comment, subscribe. See you in my next video. I mean, global math teacher.